live button.
Oh, it says it's got it. Being
But
sent
it's not
live.
yet. I think it's not yet there. Yeah, it's been many months
It
since
says the meeting is now streaming live on YouTube.
I know, but if
Oh,
you
Hello
check
world.
YouTube- No,
The world
not yet.
is us.
Not
No?
yet. Not yet. No. Oh, actually,
It
yes. So
Yes.
we're live. Okay.
We're live.
We're
Hello,
live.
everyone.
All right. Hello.
We have
We are-
one.
We are all wearing our contributor t-shirts.
Right. T-shirts. So yeah, made during previous sessions, I guess. But we need to thank who we need to thank.
Ferret DB.
FairDB, okay. But also, I would start with Andrey actually because he made most of the work, actual work.
I was just hitting keys on keyboard.
Uh,
That's-
He was
So-
proving that theorem about monkeys and Shakespeare.
As someone who is dealing a lot with AI stuff like LLM and so on, I can say Andrey is much better still. So, yeah, I like. Where do we start? Let's start about talking about recent successes and committed patches, right?
Let's start.
Ma-
In January, we got a lot of
January.
stuff ready for committer. And we started with UUID v7, which is ready for committer on CommitFest now, but unfortunately, it's still not ready in RFC. I don't know what are perspectives, and committers do not want to commit it until it is officially UUID v7 because it changed a lot previously. Actually, RFC from 2022 is much different from today's RFC. It has now a counter. It has now some specific requirements regarding time source and all the stuff. It's all needs, but the format is different. So makes sense to wait until it's finalized.
Yeah, it means that there might be more changes, right? Last minute changes. But the main battle was in PGSQL hackers mailing list. The main battle was around should we have ability a function to extract timestamp from this UUID version 7, right?
Yes. No.
No. Yes. No.
That battle that we won, I think the function is still in the patch, and the function
we won it on Postgres territory, but those guys who participate in this standard RFC development are not happy with it, right? So there is disagreement, or maybe I misunderstood it.
It's been 1 month, and I already forgot. Maybe let's check in mailing list.
Okay. But we do need it because, for example, for partitioning, we need such function.
Let me just recap the issue for people catching up late. So UUID v7 is sortable because the front end of the UUID is basically a date timestamp. The tail end is random number, and now they're inserting a counter increment piece. Anyways, but if you break that up that way, the upside is that your UUIDs insert, okay, always in the same direction into the database, which causes less page splitting in the indexes, etc. This is what makes it efficient based on our ULID conversation in the past. Now, the issue is that with this one ID, if you write a simple function, you should be able to extract that timestamp out of there and then use that timestamp as your partitioning piece, right? And that should work great. Unfortunately, arguments come in. Well, is that really valid? Is it a valid timestamp? All this other stuff started coming in, and that was kind of the argument that was coming out. Did that summarize it? The basic to bring people up to speed? And then I'm sorry. Now go ahead, Andrey. Now, what were they talking about in the email mailing list?
Yeah, you're like explaining it much better than I do. I just remember all the small needs that might be not very important. And you mentioned that UID is always ordered in the same direction, and it was not precisely true in the versions that we implemented online, because it was using timestamp, and when you generated high frequency, more than like 1,000 in 1 millisecond, they get randomly ordered. They could get randomly ordered. And latest revisions of UUID v7 implies that you have a special counter zone, which kicks in when you generate new identifiers with timestamp not advancing.
Okay.
It might even leap back, and if this happens, new identifiers are generated with incrementing this counter. And the interesting part, neat stuff in RFC, is that this counter look like random numbers until it starts ticking. So when the time tick, it is filled with random bits, except leading zero to give it a counting capacity. And when you generate same numbers, it is incremented with different leaps forward, so you cannot predict how it's ticking. In our implementation in Postgres, it is incrementally always by
Simply
one.
incremented. Yeah,
Yes.
simply incremented.
Yes.
That's an interesting. So it's not just filling a zero in that spot all the time when it doesn't need it. But what does happen is the minute you use the same date timestamp effectively, then it knows that the next one actually has to increment higher than the previous one. So it feels like a normal increment, right? So basically, if it was going to be a collision on the date timestamp, right, down to whatever granularity, then this thing actually increments. And it should only happen a few times in a row, like based on the fact it does take a little bit of time, even on today's machines, to generate these values and to do an insert.
Yes, and even if you overflow this counter, it will simply increment millisecond counter. So you cannot overflow it unless you can overflow year 9,000 something. After year 9,000 something, you will wrap around.
But that's interesting, because if you increment the milliseconds, the odds of a collision in the future on the other milliseconds that you just incremented just happened, right? So, but I'm assuming that the counter is kind of static and only resets when it gets a new timestamp relative to that initial value. That's interesting. I didn't read that code.
And a few more needs. This state of a counter is backend local, so it's specific for a single connection. And there was some problem in other programming languages, not in Postgres, that now it's stateful. And when you reuse the same counter on many cores of CPUs, it is doing false cache line sharing. When you generate next UID on one core, you send invalidation to cache line of other core. And it is now a bad thing to use a globally shared UID generator. So it's a good idea to have a lot of generators, one per server CPU.
And that's interesting, because I didn't know if it was the V7, but one of the Vs, like V9 or something, actually had a byte reserved for the actual machine or CPU. You could literally use that to code that into the value to prevent that kind of collision, right? So they were then, putting that in the mix. So you got the timestamp, you've got the sequence counter, and then you've got the server, I called it server byte, and then you've got the random, right?
Exactly,
and that gives
byte.
you, exactly, it's 1 byte, but it's 200. Look, if you have more than 255 servers or processors, you've got a different set of problems.
Actually, it was a single byte, and unfortunately, it was called, and now it's gone from RFC. I didn't know why. I didn't
Oh, they
follow the
removed it.
discussion. Yes, it's not.
Oh,
It was in UADV8, and now it's not there. I don't know why. But now UADV8 is just custom 16 bytes. Just do whatever you want. Just set a version and variant field, and other bytes could be whatever you use. Store your stuff there, photos or maybe videos, and any.
So Kirk started the explanation for folks who like lagging in what's happening and why this UID v7 is needed at all. And we have a question in chat. Thank you for that. I didn't expect questions in chat today at all. So the question is, why not stick to a time or date and the serial? In big int, there are 19 decimal place, plenty of space for them both. I can answer it. So because we have distributed systems a lot of them right now, we have a lot of like if we use serial, big serial, they are local, and timestamps sometimes also clocks are shifted or something. So UID versions 4, which became popular, it's totally random stuff, right? So it's good for systems where we have microservices or something like many clusters, many primary nodes, and ID can be generated on any of them, or sharding maybe, or something like that. So it was good because it was like, oh, okay, we generate some random number, we don't have collisions anymore. But it was the other side of whole range, right? Spectrum, right? So if we have absolutely random value, it's not good for B-tree. We discussed it, right? So it's not good for performance. So UID version 7 tries to combine benefits from both worlds, like sequentially generated values and random values. So performance is good, but we also can use this on multiple primaries. Right? We can generate it from multiple places.
On anything that generates data, it can lack operating system. It can have no file system at all. It can have no, almost no. It can be
Serverless.
Arduino. Yes, computerless. Like
JavaScript.
it can have no source of real time, but still it can generate UUID. It can just send you temperature and UUID. It can be a very stupid device. It must generate random number, but it can get random number from the same temperature, something like that. And you just need several transistors to solder together, and they will get you UUID. V4, V7 is complicated. Even in the code, it's almost 100 line of code. So soldering UUID v7 generator is a complex task.
But back to my question about extraction of timestamp. For partitioning, we do need this timestamp because this is how our partitions are. If partitions are time-based,
so let's
schema is
just
time-based.
check what was. Let's recap what is in hackers. Check.
Can you zoom a little bit? Font is too small.
So I will scroll from the bottom. So let's see the code that was. We have a shorthand of UID v4. UUID v7, extract time, extract version, and extract variant. So we still have this function to extract time. We don't have a function to put time in, but the function to get time back is still there.
It's great. So
So,
basically,
and
in many cases, if precision is enough, we can avoid created at timestamp tz column at all, right? And just rely on this value. We just have primary key, UID v7 primary key, and we have everything, and we can just extract timestamp from it. If we need creation time, right? And
by
also
the
use
way,
it in partitioning.
Also-
timescale DB, for example.
Also, I want to just remind everybody, one of the reasons this becomes important, yes, we could also insert a date time, a timestamp field and use that, but now we're wasting space because it's essentially already in, and the UUID is a big enough key. So it's already there. So why would you want to add another whole field just
8 bytes.
to replicate what you are, another 8 bytes to every record across whatever, 1 billion rows, when the data is already there, and most people aren't partitioning on milliseconds. Like if you're using it for partitioning data, and for ordering, same concept, right? Could you get partitioning by
usually
milliseconds?
it's like most frequent, let's say aggressive partitioning was hourly, as I saw. Every hour new partition, but it's very high insert rate and so on.
Right, and so this is more than good enough and it's orders of magnitude better than the current state of the art, which is, for me, that's the litmus test. If you're at least one order of magnitude or two beyond what anybody can imagine happening today, this is going to last for a while. So that's kind of my argument.
Yeah, that's good. I'm already using, but I generated on client side. Our bot is using UID for like a lot of stuff, and we have timescale DB partitioning based on that. I wrote some how-to about it, but just in case, why do we need, we can use it outside Postgres already? And Andrey sent me links, and in PM, so JavaScript library exists already, and Google already updated implementing v7, or even if RFC is not finalized.
There they have a non-compliant version, and they don't care.
So Postgres is more strict and conservative, obviously, not rushing into committing this.
Yeah, because we will get them on disk and they will be persistent. Google can just reset.
And we actually have a PGSQL version and even SQL version of this. This is what I used. But why do we need it to be present in core? This patch should be committed. Why? If people can use it outside.
Speed and consistency are mine. It's faster code than PLPG SQL would be. And inconsistency, meaning it's working the same in all your versions of Postgres. And then that makes it easier as you move it to a new version, and things like that. So, I mean, from convenience too, quite frankly, 80% of people are going to use what comes out of the box and not
Defaults.
add that extra complexity, right? Look, some people still have 4.0 set for their random, sequential access, right? Because they don't know they should be set into 1.1 if they're using SSDs, right? Because it's a default. And so by default, I think that's powerful. I wanted to comment on something else, though. This is a long, slow process, and the slowness is a function of Postgres wanting to be stable, right? And as well as them not wanting to have to undo and create future problems. So I kind of respect this, but that also means what number of patches have been approved for you, Andrey? Because we have quite a few in the pipeline. So how many have been committed this time around?
Right?
Do you have just ballpark? Yeah. Do you know what's in the commit path that you're involved in? Because we normally only expect 1 or 2 to show up, right?
Yes. So I was reviewer of some patches. My patch on Gist Engine is hanging still for some years, but it's okay.
For some years.
Yeah.
Years.
Years is what it takes for some of these to get in. So this is not for the faint of heart. Okay,
Yes.
this takes time.
SLR optimizations patch actually was committed yesterday by.
This is huge, right?
Yeah, we can discuss that. And I think transaction timeout was committed to recently. So,
But now it says moved to next CF, so it was
Yeah.
aborted.
Why does it say move to
reported.
next commit fest?
Maybe
Both
just
of
because
it's committed.
it's because it's manual process to maintain consistency because commit fast entries and the actual state of the code, right?
So it was
sometimes-
actually committed. So let me flag it.
Right, it was committed, but with some comments.
I can't. I don't have privileges to do so. So it is committed. I think
Okay.
Alexander will move it to committed state.
Yeah. I'm
So
going
I'd
to
say
think
that maybe almost 1/3 of my patches was committed through January commit fest or February.
Dude!
This is
Dude!
cool.
For PG-17, a third of your
Yes.
patches. Yeah, and some of these, you can see that one. That one started back in 2022 or whatever. So it's 2024. So some of these can take a couple years to get flushed out. So
Yeah. And actually, transaction timeout was started precisely a year, maybe a year and 2 months ago. So it's 1 year to get a major feature committed. It sounds good.
wow.
This particular patch started in
There you go.
2020, so it was long
Yeah.
road.
Yeah. Yeah, and
Wow.
in the middle of it, I had cases when also sub-transactions is related. Sub-transactions, my big article about how I dislike them and so on. This is very related work, but I still need to check the final version of this code if it helps in the problems we had
Yeah.
with sub-transactions.
That's the patch. It was committed yesterday.
So algorithm is changed, right? It's the algorithm, SLRU algorithm.
There was a completely new login protocol for SLRU written by Dilip. It's not about caching. So in single-threaded backend, everything seems the same, but logs are now much more granular. And actually, Dilip demonstrated it on some specific workload that it can increase performance like twofold or something like that. I think we can find it on Commit Fest. His comments. Oh, maybe here is a link on yeah, in the commit there is a link on discussion. And yeah, so in some cases, better locking was improving.
There you go. I saw the percentages.
2 times more transactions per second with better locking. But anyway, you can get to this this performance is regarding some anomalous workloads when you have a lot of sub-transactions or when you are doing a lot of select for update and select for share, select for key share. Normally, if you are issuing only updates and selects, you cannot get many locks on a row. If you lock it, you lock it for update in exclusive mode, and you don't have 2 locks on the same row. Multi-transaction is when you lock the same row twice. And to get to this, you have to issue select for update or select for key share. So if you are not doing this, multi-transactions are never a problem for you, as far as I know.
Mhm.
But sub-transactions can be problem if you use PLPG SQL and handling errors there, because that's how PLPG SQL is working.
Begin except when blocks, except end, except when.
Yeah.
Exception when. Except is Python. I write too much Python lately, so exception when end blocks. but we can use subtransactions explicitly, and some folks using ORMs like Django or Rails, sometimes they use subtransactions even not recognizing it's happening. So at some point,
now if you are doing benchmarks, you can take a Gook G.
The Guck, yeah, views fees,
setting.
a setting.
Yes. Subtran something subtransaction buffers, and set it to some huge number like megabyte or something like that. And
Yeah,
it must be better.
great. That's great. We in our case we needed the problem happened on replicas only in our case. So I'm going to test it with our bot definitely, but we need first to teach the bot to produce workload on replicas. It cannot do it yet.
There is interesting stuff that some problems on replica were caused by one problem that was not fixed yet, but Alvaro said that he is on it. He is considering this. There is a case when here, I'm sorry, I have just a backtrace here. So when you are on replica reading recently generated multi-exact on replica, you have to issue sleep unconditional. I think it's not a case of subtransactions, just
No, it's not. I didn't have multi-exact at all involved. It was purely subtransaction. It's just one transaction using just single subtransaction, and that's it. But at high rate, and also concurrently one open transaction with assigned real transaction ID doing nothing, just open. That's it on the primary, and then on replicas you have terrible performance issues. Multi-exact was not involved at all. It was different case. Subtransactions plus multi-exact can be a problem, but it's a different case.
So this thread from 2020 is now at the point where Alvaro is considering fixing the problem, and we are looking for good tests. And today, Kitara told that the solution that he coded back in 2020 may have some issues. So it's a kind of like a big change did happen, Ray, but there are some to-do things that we are going to still work on. The work is not finished yet.
And here we talk about really heavy workloads when these problems are
yeah, this particular problem is reproducible only when you have a heavy multi-transactions read on a standby. In your case, you only have heavy workload on a subtransaction system. If you do not overload your system, you won't see this much performance gain from this. So this is this stuff that saves from a pathological problems,
edge cases. Yes, moving edges further from like performance cliffs also
removing edges entirely. This particular edge entirely.
Anyway, this is huge work. It feels like big work, and it looks like 4 years, right? So it's big. Congratulations. I hope I will find time soon to explore for our cases. Before Postgres 17 is out, obviously, we have deadline here.
Yeah, the other patch that we were working on is a transaction timeout.
I didn't expect that it would be committed for 17, honestly. Like everyone agrees that it's needed, but like no support. Like
there's a lot of folks really waiting for this stuff.
Right.
And it got committed. It was somewhat reworked by committer Alexander Korotkov. And currently there is like it passes all the tests. We implemented a lot of different tests for this feature, and these tests were too complex. They were failing a lot, and currently all tests are removed, unfortunately, and we need to write new tests for transaction timeout. So at the time, there was a specific test which was called timeouts long, and it was testing two things. First, commit and chain. Did you know that commit and chain exists at all? I never used it.
Commit and chain.
Yes, you can commit and start a new transaction
What?
immediately.
I didn't see it. First time I see it.
Yes,
Wow. Wow. So we can, instead of commit, we can say commit and chain.
yes.
Does it create it into like a sub transaction then by doing it that way?
I think it's separate regular transaction.
No, it starts
just
new
right.
transaction.
It's just
Or
it's like commit and begin just in one
In-
shot, right? To save on RTT, round
yes.
trip time.
And we had
That's
a test
simple.
that is restarting timer. So that when you're doing commit and chain, you are starting next transaction timeout. And this test had to verify two things. First, that the timeout does not happen if you combine two steps, like sleep, commit, and chain sleep, and that here you don't still get a timeout. And then we had to change when the second transaction finally gets through time overflow, it is getting timed out. It's getting fatal. So it's quite complex test, which have to be very long. So I could make it stable on most of build farm animals when it is almost a second long. So that's why the file for test is called transaction timeouts long. And the other test was so-called Nix case, when you have a stream of small transactions.
Right. And the wait time between not transaction statements inside one transaction. So brief statement, brief pause, brief statement, brief pause. So we don't break statement timeout and we don't break idle transaction session timeout. Right? So we don't
Yeah.
achieve them.
So this test was somewhat complex too. It contained 1, 2, 3, 4, 6, 7, 8, 9 steps. And to make it stable, it had to run for 1 second too. And actually, we try to save time of running tests because, like, every hacker is waiting for test results. You can't just waste 2 seconds from every hacker ever hacking on Postgres in the future. So, but that was not biggest problem. Biggest problem was that these tests resulted to be unstable, and in future commits, in a day after commit, Alexander reverted tests. In following week, other tests start to fail. These more simple tests that test interaction between transaction timeout, idle in transaction timeout, idle in transaction session timeout, and other timeouts. First, our session 6 was timing out, that is testing statement timeout versus transaction timeout. But then other stuff started to popping up. Let's see the history. Build farm failures. Almost all isolation check timeouts are ours, unfortunately.
So for the slow people like me, just to recap where we're at, the patch is done, the code is there. The testing is about the animal farm testing, which is part of our continuous integration and testing stuff. that make sure that we're not breaking things in the future. And that's an important part of Postgres and its stability. I will argue that Postgres is stable because of all of the what we call animal farm testing. But there's also, when you're developing, there's a make check process which actually runs these tests. And this is where the speed of the tests becomes really critical, because this is every developer bumps into this. Yes, it affects the build farm speed for testing, but no one's sitting there waiting feverishly for that as much as they are on their own machine. And they're compiling and they're testing something else differently, but they want to make sure they didn't break anything. And if every test, and there's 1,000 of them, say, took a second or two to run, all of a sudden your build times and your make check times would just be so abusive to you that you do them less and less. And everyone who understands testing understands you want testing to be done more and more frequently to find bugs. So that is kind of why we're attacking this. So now the issue becomes is our tests are failing. They're kind of failing maybe randomly. So now we have to rethink the tests and understand what's kind of tripping them to cause them to fail. We want to keep them fast. We want to validate that they're working, and we want to make sure nobody else is submitting code that's breaking this. So, and then you've been driving into the details, and I apologize for, kind of just giving other people that explanation, and also making sure I understand it. So
yes, all your details are really good for our discussion. So 9 days ago, we started isolation test failures, as you see previously. It was happening from time to time in other branches, but it's definitely not our fault. I think. I hope. Transaction timeout was not committed to Postgres 13 or 14. So we are interested only in failures in master branch head. So 9 days ago it started, and it always looks like this. Yes, that's a bingo fail actually. All 3 tests failed simultaneously. So what the failure is? We see S3 check, S4 check, and S5 check failed. So we were selecting from stat activity, checking the session S5 is gone, but it's not. We count one backend that is named session 5. Let's see what's there.
So this test is basically saying, hey, we've run the other timeout tests. Now we're going to check PG stat activity and say PG stat statements for activity and say, are these things still running? We queued them up. Now we're going to check to see if they're still running. If they are, that's bad because they should have timed out already.
Yes.
Perfect.
So S6 is a start 6 beginner transaction. Schedule transaction timeout after the transaction actually started. So this is the check that you can initiate transaction timeout in already running transaction. Then check your sleep. Wait.
Did you say you can or you can't?
You can.
You
It
can.
works.
Okay, good. So you already did a begin semicolon in P-SQL, but you want to be careful. And for testing, you're going to execute the set for the GUC. And then after that, it should work. And it should understand the difference between what you're doing. Okay?
Yes, it's not exactly what you might expect. So if you start a transaction, then 1 second passes, and you start a transaction timeout for 1 second, you have 1 more second. The second that passed already, that is not subtracted from your timeout. That's how it works, and we had a test for this. And this test, session 6, is finished with S6 check, that the transaction is actually gone. And on some slow machines, and most of the time on machines, when the sanitizers were turned on and sleep time was somewhat random, we were observing that backends are still there in stat activity. Maybe if we checked that they are in aborting transaction on and the others.
That was exactly where my mind was. My problem is I don't know the status of these things. And so they could be sitting there as an aborted transaction, which may be the correct answer, right? That this transaction's not actively running. So
I just don't know. Look, that's an interesting idea, but to verify this idea, we have to restore back these tests. The
oh,
failure rate of one fail per day. So the whole build farm is usually passing all these tests smoothly, but one fail per day, or maybe even less.
all right. One fail per day sounds like a clock rollover problem. Like, I mean, just, personal experience, right? It's like you're timing something and midnight struck and you roll over and now you're looking at time and time is backwards. But that said, how could we trust the PG stat activity question? So if you have a working version of this, if we create it in one session and in another session, we query PG stat activity and check the status, do the select asterisk, not just the count, but whatever. Let's figure out what columns we're paying attention to and let that run until it times out. And then see, does it just really drop out? Or, right, does it actually go to a status where we know that it's been being canceled and maybe Postgres just hasn't had to have the time yet to clean it up? And we might be sitting there looking at something because the count alone may not be enough, I think. But we could probably recreate that pretty easily. And it's just to test the hypotheses or the theory at this point. I don't know.
I don't know. I didn't think about it. Okay, so currently my plan is for this problem is simpler. The problem is that we are waiting and the time is not enough. Like we must wait longer on some machines. And on some machines, we don't have to wait that time. And I'm planning to reuse new test technology. Recently, Michel Paquet, Michael Paquet, Michel Paquet, I think.
I thought
How
it was
his
Michael.
Michael?
Let's allow be very wrong with names ourselves. If someone blames me in pronunciation or at my some name wrong, I can ask to pronounce my name. It will be a challenge. So, names are hard. Naming is hard, right?
Naming is hard. Yes.
Yeah.
My daughter X9 will confirm that.
So recently there was proposed a technology which is called injection points. And this injection points allows you to plant in some code that can hang for a while and you can observe that it happened. So you don't have to like check some other signs that the backend is gone. You can check that it was going to die. It was going to quit. So, and my plan is to take these patches from Michael and reuse it to create more stable version of transaction timeout tests. And if we do this, we can save the time on fast machines because we will observe that the test quit almost immediately. We can set a timeout of few milliseconds and it will quit fast. And on slow machines, we can wait arbitrary time, like say an hour or so. If it's necessary to wait here, let's wait to be sure that check quits as expected.
And will you set it up to only wait while it's failing to see the behavior? So it's an optimized wait. So if it sees the back end is gone, okay, or not in transaction, then we can actually exit early, even if that time didn't expire. So we'll wait up to an hour for example, on a slow machine, but it's up to an hour. And maybe it's up to an hour while we check, whatever, however frequent. So that's effectively what you're going after, right?
Yeah, that's the whole point of what I'm going to do. But the problem is these patches are not committed yet, and they are being actively developed. This morning, Bertrand Drouveau added one more
days ago.
function that I need.
Yesterday.
Sorry, what?
I say it's like 2 days ago, yesterday, so it's really happening right now.
Yeah, yesterday.
So the risk
No,
is if this is the only way we can fix the test and this doesn't get pushed into the patch or this doesn't get committed, this can negatively impact us, right? If this doesn't make the commit cycle.
yeah, it's the thing is there were no timeouts for idling transaction and statement timeout at all. And these features worked for a very long time, so nobody broken it. So probably transaction timeout would be fine too, but we would be much more like safer, I know, to sleep better if we know that there are tests for the things that we introduced.
Right.
Yeah. So the plan is to take this patches
Michael?
from Michael and this patch from Bertrand, compose it together and produce a test that is like good for uh, uh, good to test our feature. So how do you think, should we do it now or next time, or
If you have energy right now, let's
I
start,
think we
right?
can start.
Yeah.
I think we can
Yeah.
start. And actually, I was already doing something very close, but not precisely there. I have started to work on this. I created a branch transaction timeout follow-up for myself, but where are we now? All the stuff. There is a small prototype, and let's format it. Now let's get back to master branch. And check out detach head. Apply patches from Michael. Let's pick latest version. What was latest version? We were discussing some stuff there. Here, before. Load this. Or And also a patch from Bertrand. Latest version. So our patch is on top of a patch, on top of a patch, on top of a patch.
Dependencies.
Yes, and they are all in the head now. That's okay. Um, 18. So all the other stuff is applied, and let's apply prototype of my test timeout. Let's configure. Now, when we configure, we have to use this stuff, enable injection points, because
Well,
without
1 second. Did your previous command fail? The add timeout taps test patch? You were supposed to do a get AM, correct?
true. Yes,
I
you're right.
just
Thanks for
no.
following.
That's why the dumb guy is here.
So it is now right. It is now configuring, and while it's being configured, let's go to code and see what's there. This patch it's this test, which is in a test model test miscellaneous. Never could pronounce this. How is it pronounced?
It's short for miscellaneous, like miscellaneous. Miscellaneous. There you go.
So this test should be skipped if injection points are not compiled in. Then it creates extension injection points. There is a transaction timeout injection point. Let's see how it looks like. So in a place where we are going to throw fatal to user, I've added injection point. In a test, we will tell the Postgres that it should hang on if it observes injection point at this place. Also, the patch adds injection point in idle session timeout and idle in transaction session timeout. And then we are doing simple things. We say injection point attach wait, and here is the wrong part. It is using background PSQL. No, it's correct part. It's starting background PSQL and trying to time it out, setting a transaction timeout to 1 millisecond. I was hesitant to make the test this way. First start a transaction and then set a transaction timeout. The problem on small machines is that you can get timeout before anything else happens. And then you are unrolling this timeout because timeout happened.
So just this quick question. Would it be better to have 2 set transaction timeouts? One where we set it to like a full second before the begin semicolon, so that by itself would never time out. And then we reset the transaction timeout to 1 millisecond inside, which then should time out after a millisecond.
But default is 0, so unlimited anyway.
Okay. So the default is 0 and it shouldn't be set after this for any reason because it just started up. Okay.
I just understood that problem may still be there, but anyway, let's get back to test structure.
By the way, set local would work as well, right? It's inside big.
Yeah. Set local transaction timeout.
When we limit it only for
Maybe
okay,
this part is
unrelated.
gone, and we should replace it with code from Bertrand. In his patch, he's implementing a feature which is wait for injection point. Let's copy it from usage. So in a test, we can now do something like that. We are waiting transaction timeout from a regular backend. This should now work on my machine, and I will tell you later what's the problem with this test. Let's try to run it.
So I'm sorry, I saw node and node standby. What was the difference between those two node lines? Everywhere else we're using node.
Just simply a mistake. In a patch that Bertrand
No,
sent,
that's okay. That's what I thought it might be. That's why I asked.
yeah, in Bertrand's patch, he's issuing it on a replication standby. But here we have just node is a local variable, which is for a cluster, which this is a stuff to control one cluster that is created for test. So it must work now. Let's check that it works. It's in sources test.
Did you recompile after the change in the save? Because you had popped out.
When you're running tests, they will recompile it automatically.
Okay, cool.
So just make check.
There you go.
To shorten our test, do not run other tests. We can say prove tests T005 timeouts PL. It should run only one test now.
We learn something new every day. By the way, Nikolay, that would be great to copy and paste that command in the show notes. If there's one takeaway for someone learning this stuff.
Yeah, my Windows background changed stuff slightly. I was using wrong.
Yeah, backslash, like Windows.
Yeah. So now this test is passing, seems to be passing. But there are two problems with this test. First one, and simple one, that we are checking a very simple scenario. I want to do here something like select one, and then you know what? Watch. So this background PSQL should be hanging and watching select one and select one and select one. But this test will fail, I think. So now we have a stream of select ones, and it's failing. Let's see logs.
All right, change the select to a select of asleep for 1 second for me. And I bet that one will pass. My hypothesis is that what's happening is we're catching the code that's running inside of the watch stuff inside of what is it called? pSQL. So it's actually re-executing that command despite being told the previous one failed.
We actually added iteration count.
There you go.
And period. But period is in seconds. And in tests we in fact want milliseconds. And I think this won't work.
Why? It should work. I use it all the time. I mean, I use \watch 0.2, for example, all the time. Yes.
I didn't know that. Did we?
Sometimes I'm showing like every like delays 100 milliseconds.
Now you might have to have a leading zero. I don't know if having a period first. I just don't know. So
I use \watch space dot two, for example. It works, but not with not named parameters. It's my own.
That's
code.
actually fast.
Good. So it was right guess, maybe.
Maybe.
yeah. So what's happened? So my hypothesis was the immediate transaction actually finished the select, and even if it threw an error because it was busy, then the watch kicks in because the watch has no way of knowing that it shouldn't run it again because it timed out and it hit a transaction timeout. There's no such thing as watch until or watch if that would have told it to stop running.
No, if an error happens, watch stops always, right?
Does it?
Yes.
Yeah, I think
Oh,
so.
maybe I'm
I use the division by
Yeah,
zero
yeah.
to make the watch stop.
To make the
many
watch
times.
stop. Oh,
Yes.
so this could be.
So it's something else. We don't understand what's happening.
Don't see this. I don't see select one in
In the log saying it failed.
So I see begin. It was there.
Select sleep we now have, right?
Yeah, it says select.
Yeah. No, it's not sleep. It's just select
okay.
one. Maybe should I add semicolon here?
No, it's not.
No, that runs it twice. I learned that from Tom Lane's comment to my email. So the end of the select one semi will run the first one, and then it'll run after that.
But now we have at least one select one.
Okay.
Yeah.
But where are others? Maybe PSQL.
Well, we have fatal terminating connection, and then watch is not working because of an error.
Right.
It stops.
So that actually worked correctly.
Let's add longer timeout. I hope you guys have 100 milliseconds to wait.
Oh, let me check my watch.
See, I'll be much surprised if it is working.
It passed.
But still, there's still just one select. I don't see select ones, and I want to see a stream of selects.
Does watch create the stream of selects normally?
It should.
Can we copy and paste this test without the timeout piece enabled and just validate our assumption that we would see begin select one, select one, select one, and just do it with a count on our watch for 5 times?
Just a second, I will remember where do I install it. Let's do it in pSQL. I think I didn't issue select one single time.
Well, you've got your session timeout is set to 100 milliseconds.
Maybe I'm wrong in P. What's P?
Let's try infinite watch. Let's use old syntax, just watch, and then you say how much to wait, and that's it. Without named parameters at all.
Like this?
Yeah, yes. This should issue first statement, then wait specified amount of time. I just checked it on, but I checked it on older version of Postgres.
Oh.
So we have select one, right? Just one, or no?
Yes, we have a lot of select ones. I think we should have like 100 or so.
Right.
That's fine.
Let's get to 10. This code should get us approximately 10. Should we count? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. This is almost exactly 10. Cool. So let's check it in test.
Maybe you found issue with different patch named parameters, so with watch. Maybe, but it's another story. Because the behavior is different from the old syntax.
It's passing. Let's see logs. It's passing, and it's in fact doing a stream of selects, and then the transaction.
So something is wrong with not named parameters.
And it's, by the way, it's I, not P. So I is equal to the number of seconds. I and C are the variables to /watch. /watch, it's I for, yeah, it was I and C. C for the count and I for the number of seconds.
This went to Postgres 16, right?
Yeah, I'm on 16. They didn't, I don't think they changed that.
I have this on my t-shirt.
Yeah, that included it. Oh, good for you.
But your version is without named parameters.
Yes, I don't have a help message here. Next time I will print a...
No,
I just looked it up on PG16.
Remember, we first implemented without named parameters. We just wanted like a number and number. But then someone said, let's have named parameters.
I do not remember which
I think it was Tom Lane.
Good, but no one said let's have whole words for parameters. So because one letter is very hard to deal with.
Well, and I to me means iteration, like so yes, as opposed to time. Yeah. Okay.
Interesting. So that we have 11 queries here, not 10. I don't know why. Maybe that's the case. That's the problem.
Oh, actually, you can write interval equals. Yeah, I'm checking and count. So if there are two parameters, interval and count.
Interval, right.
But how come it worked with P if P is not supported?
Oh, maybe it threw an error after executing it from the watch perspective.
Our test was expecting an error. We are expecting that PSQL will fatal out from transaction timeout.
And we were getting the fatal from the bad watch command, probably.
It's fatal, okay. It's fine.
That is a great lesson for anybody new to debugging.
But you should see the message on the recognized parameter. We didn't see the message.
Because we don't have logs from a console tool. We have only server logs.
Okay, now everything is clear. Okay.
Yes, and the last one problem is that
actually P would be correct because it's indeed pause, right? While interval, we discussed it. Interval like says it will be interval like 100 milliseconds or 10 milliseconds, but it's not because there's also
because statement duration. The time of the statement, right?
So it's we discussed this. It's misleading and it's old problem with watch.
So this test is almost done. We're good, but there is one problem that bothers me. Now imagine like here for some reason Perl is sleeping. This query will fatal out, and when we start to wait for injection point, it already happened. No, it's not a problem. I just understood. We set a wait here before ever starting transaction timeout. So I think that this test must be okay for all known problems that we observed on build farm. Let's finish the test because there are tests for idling transaction timeout too, and they are using wrong notation.
Okay, so I only have one problem with the test before we move on. I would prefer we fix the parameters and send them and put a count here. Because my problem is, if it never throws an error because of bug, how does this end? We have an infinite loop here.
Wait for injection point will time out in 100.
Oh, because it's doing it in the background. Got it. Okay.
Yeah.
So when that
We can
file,
limit a loop if like now we realized the problem was just wrong parameter name. We can limit.
I would prefer to put good parameters on there.
Just for additional safety, right?
Yeah.
I don't get your idea.
So infinite loop is dangerous. It can make tests long.
You mean this?
L-
Oh,
Yeah.
let's if
somebody
you if
So
you just use finite number of loops and just use the correct names for parameters, maybe
Yeah.
it's better.
So the
That's-
correct parameters are I equals for the number of
Right.
seconds. So put I equals in front of that. And then at the end, put C equals, and then you can say 100 because it should never get that many, or how many you want it to be, 9999, I don't care. Just infinite to me is bad.
No. The thing is, imagine that we have broken this timeout, that it is restarting with every statement. We
Okay.
need to check that it is so in presence of infinite number of transactions, it's not timing out. But the test will pass because we have a limited number of. So if
but test expects an error if we have limited number and it finishes without error.
so if
Yeah,
we put 10,000 in 20 minutes, it will be gone. And if the overall timeout is maybe, I don't know, hour or so, we will miss the problem.
How come this problem? The test expects that result should be an error, but if we reach we execute all the loops, there will not be an error. So
it's easy to prove. Set the count equal to 1 right now and test the code.
Actually, yes. Right.
That will prove is if this
fail.
catches the error, and this should fail back because there was no exception thrown. So when you check for wait for transaction timeout, it should say there was no transaction timeout. It failed.
I do not understand, but I can
If
do
code is executed successfully, it's a problem, and the test should say I'm failing because everything was okay. I'm like it's an inverted logic, right?
Yes,
we
don't check here.
Let's check.
Right, that's the correct fix, though. To me,
Yes,
that's the
let's
correct
check.
fix. We need to make this test fail because we know that the test did not test what it was supposed to test. It did not trap a failure.
Currently, we don't have means to check background session output because this
That's bad.
this function query until it is cleaning the out. Let's try, but I'm not good enough in Perl to know how it's done.
But if we don't check successful execution versus failure,
we check that we have server failure, but we don't check client failure.
But hold on. If you're checking for server failure, what are you actually checking? Because we didn't have a server failure, and that check came back and said it passed. So let's look at wait for injection point transaction timeout. That's actually waiting for us to say, yes, a transaction timeout happened, right? So it's sitting there and waiting. The question is, does that return a value that says, yeah, we never got that?
We can't check this value because on Windows, like fatal sometimes looks like a just disconnection. Server closed connection unexpectedly, etc. And you do not even know that it's fatal because for some synchronization logic, you just get a TCP reset. Let's see what was printed in this variable.
Now, did you fix it so it doesn't set that to quote, quote? the code you stole that from was forcing it. Go into the background P-SQL or the query until. Go into query until again and make sure you don't set it to quote, quote. Because it was saying, the standard out equals quote, quote in there, if I remember the code correctly. Just control click on query until, P-SQL session query until line 33. Jump back into that code, line 33. Yeah, good. You see the bottom line here, self standard out equals quote, quote. It's overriding the standard out. Oh, is this appending to it? Yeah, comment this line out. Comment that line out so that the other one, the return value. Look at that. We can pull the return value. Slow down. Notice how return value is set to the standard out and it returns return value. So now our call, let's go to the query until call, back out. Good. Now assign that result to a variable. Give me a $var in front of the P-SQL session call. Yeah, perfect. $, Kirk. You got to put $1 in front of me. Awesome.
So we have Perl expert here.
Yeah. Please don't leave that in there long term. But now let's print that variable because that's actually the return variable that's coming back. And I don't program in Perl either, so I'm just a really good guesser.
Let's try.
That's what I like about you, Andrey. Let's try.
I do not even know which logs will contain this stuff. Probably this. Let's look fatal.
How else do they print things during the test? Like they print the test updated, test complete in their other scripts. How do they do that?
I don't know. Let's do this. Maybe at some point I will start learning Perl. So here is this.
Oh, okay. Hello world. And then, so we should put a terminating comment too, but it says starting background P-SQL. Okay, now let's force the error. Change the count this time. Good. Now we see the output. So now change the count to, or leave it infinite. That's good.
Broken pipe.
All right, at Perl line. So there's a broken pipe.
It's interesting because this broken pipe is when we try to close this. When broken pipe is from this quit. When we are doing quit, we are sending to psql /q. We are like terminating a session.
Just to validate, put a \n after your hello world, and then put it after, and then replicate the line 2 lines down. Add it after the Kirk's bar so it serves as quotes. Yeah, perfect. There you go, however you do it. So we're not getting anything out on the screen. The difference is that the pipe was broken because it was killed. Correct?
PSQL quit before we send Q to Z to it.
Right. Now my next question is there a valid way to test for that situation?
I think now it is just it fails all the time. We can just do not quit. It won't
Well,
be
hold
stable.
on, hold on. It's what's failing is the testing harness is failing because the connection was destroyed, right?
Mm-hmm.
Okay, so the harness itself is failing because the correct thing happened. We actually terminated the back end and we lost the ability to talk to this thing. Now, the interesting part is we just don't know that happened.
Okay, but what to do with?
Yeah.
I
So
don't
the
have.
return valuable isn't useful, but it highlights the dilemma. Now, right?
Let's print this std out too. Uh,
Should be quote, quote.
hmm?
It should be quote, quote. It should be nothing because it was being set at the end after the return or before the return statement to nothing in the code.
Yeah, it's empty. I know it's something somewhere here.
Yeah, but
Oh,
it's empty because we reset it at the last line of before the return statement, we set it equal to quote, quote. We destroy it. So we returned it as the return variable and then destroyed it.
we can just.
There you go. You see the code right there, the one you copied, and then it sets it to quote, quote when it's done. So the return variable is the same as what you were looking at.
We can just change something here, but I don't know what to. You proposed to comment this out.
Maybe we just like it's scripting language. Maybe we just need to put if, and if inside if we do the if use this executable code which runs our SQL snippet, right? And then if success will be in one section and else another section. I mean, just if it's an error, it should be just I don't know. First of all, it's DBI, right? I'm trying to understand what's under what's library we are using for this execution. DBI, right? It's called DBI in Perl, right? Right?
I believe so.
So usually it's just execute and else this is an error. But if it returns something, I don't know, query until, yeah.
What's on error stop if it's 0 already?
Oh, this is interesting, by the way, yeah.
That's a great question. Let's go into the function. Control click. Yeah, or however you do it.
Doesn't work here for Perl. It worked for C, and most of the time I'm writing C. So stop on error if params. So it's on error stop to PSQL. It is running PSQL with a lot of flags.
So we run PSQL and on error stop it's just PSQL parameter. It has this parameter, in CLI parameter. Yeah.
And then
So
basically, if it gets an exception, right? If it gets an error in the
right.
SQL, it actually stops the whole P-SQL.
So you found it already. Yeah. It's standard parameter. Otherwise, it says error and continues.
So hold on. So this is a problem. We're setting it to 0. Yeah, let's set it to 1. We want it to time out. We want it to stop if it gets there. Good. Now, what I don't like is in the code, I didn't like how it didn't have spaces around the equals and stuff like that. It might be worthwhile to dump the actual command it's executing out to make sure we understand it. Ooh, look, We got both values because you commented it out. Starting BG P SQL. But okay, so you see how that was all uppercase and no spaces? So I just didn't understand. Oh, it was doing it. Yeah, okay, good. You fixed that. Pop back to the other one. Go back to the other Perl module cluster or whichever one. Yeah, that one. Good. Okay, so this sets this parameter if params on air stop. Good. That should be correct now. Okay, I see how it works. It was upper and lower case, and I wanted to make sure I understood. One case it was out. That's the left-hand side is the output. The right-hand side is if the params on air stop. And I'm assuming that means if that parameter is set at all. I don't know. Maybe it's if it's a 1. Okay, good. So this pushes that param out there. Okay, that should be correct. So go ahead and run it. I'm sorry.
So
right, we can use 2. It will work the same as well, but it's okay.
We should check that session timed out. How do we do it?
Kirk's var will tell you. Kirk's var will tell you what the output was.
Exactly.
So kill this line. Just delete this line because it's redundant and we forced it to empty. Kill the P SQL session standard out.
This.
Yeah, delete that line. It's redundant. Yep, perfect. All right, so we should see if there's anything extra to see when we run this test now. Oh, good. Look. Hello, world. Oh.
There's nothing interesting, actually.
Yeah,
but
that comes out there.
But if it fails, what do we have? Now we have successful operation, right?
No.
No, it was failure. It was red.
We can move it here. Here it failed for sure. And it's still starting. I think it's only on a place where when it started, it's not showing anything.
And if it's successful, we still have only this string and that's it? If it's successful.
I believe so. Let's change the test. Give it more let it run for
it's masked.
A fixed number of times. Right. So we have just that. So let's put a count in there. Space C equals whatever number. Yep. And you see hello world. So it's the same thing, but there was no red on the previous message because it properly timed out. Right. The test ran and succeeded. The only difference is we don't see that it's broken, that the pipe broke.
So let's just leave it like that, and it will check that if something's wrong, it will hand forever, and it's fine, I think.
Well, okay. At least it's a good start. Maybe it can be improved with more experienced Perl experts.
Right. Let's
But
check where are we now. Is it possible?
I have good news. Alexander Kratkov just changed to committed. It was indeed an inconsistency. This commit fast entry.
Oh, this piece here that we're using for testing, or
no. I'm talking about previous topic about the transaction timeout commit fast entry. We discussed that it's still not marked as committed, but it's committed. So this problem is fixed.
So you want to get rid of that Kirk var?
Now it's failing all the time. It was working, but now it's not. I don't know why. Broken pipe.
Well, that should fail. You had to put the count in it to make sure that, hold on. Yeah, that's going to keep doing a watch. So that's going to keep the transaction open. Well, hold on, but that shouldn't fail. That should succeed. That should pass.
Mhm.
It was working when we didn't use name parameters. We used old syntax for watch. This is when it was working.
Yeah, let's take the I equals out just to be safe.
But yeah, so I double checked that it should work
Already
similarly.
know. The problem is in this quit.
Quit.
If we quit here, I think it will pass to.
Oh, hold on, but that quit, that's not inside an if condition. You're just quitting early. Why are you quitting at that point?
Because it is failing on some machines without this quit. So if at the end of the test we still have this pipe to P-SQL, we
Yeah.
must quit. If we don't, if it already quitted, we should not quit. So we better find the place where it's still there.
We need to, so that's it. So we need to be able to test if P-SQL session dash active or pipe active or whatever, then quit. And that is part of, and this, if you set this, that's interesting. We need something to check. And this is, I think, exactly what we bumped into here.
I'm trying to return to version when we had quit. And it was working with quit. Because now it's not working with quit too. Usually I understand what I'm calling. Not this time.
Yeah, because it's Perl.
So yeah, just time check. It's already 47 minutes of second hour. So
Yeah, it's time for us to wrap up. But let's get back in
direction
time.
is right. Some problems. Maybe some
Yeah.
right.
Some asynchronous problems with these pipes.
So if we look back at it, this was a great session, by the way. Andrey, kudos for having like a third of your stuff committed. I mean, in a single version. That's awesome. For everyone who's watched and looked at those, these things can take 3 or 4 years to push through the process. And it takes a lot of people. It takes committers, it takes reviewers, it takes, it takes the time to make sure that the testing is solid. So
build farmers also.
Build farm people, right? And then, and we're trying to support this ecosystem in what we're doing here. So awesome.
Great, guys. Thank you.
+1. Yeah, thank you so much. Congrats again for successful steps and see you later. Bye-bye.
Thank you. Bye.